Bismillahirrahmanirrahim. Electromagnetic Field Theory, and the second part of the lecture is okay. So we will start with the line charge. Okay, so first of all, we have to find the work done along a circular path. For example, if we start from this point and goes along the circular path and we'll come back to its initial point from where we have started. So this is actually the circular path. So we have to find that how much work is done in moving a unit positive charge against electric field in a circular path. Okay, for example, if we have this point, okay, this is the initial point, this is also the final point. In cylindrical coordinates, for example, it is rho phi z. So it is how much, for example, 3, this is 30 degree, and this is how much, 10. So if we move along this circular path, and this is also our final point, 3, 30, and 10. So what will be the difference? 0, 0, 0. It means dl will be equal to 0 along the circular path. So the work done at the E is in cylindrical coordinate system is in terms of the line charges. Rho L is the line charges. Okay, the charge is distributed along the line. So E is rho L over 2 pi epsilon naught rho in the direction of arrow. So as dl is 0, I have explained over here. So dl will be equal to 0, putting the values of dl is equal to 0. So the whole work done will be equal to 0. So what does it mean? It means if you move a charge along the circular path with uniform radius, so no work will be done. Okay, so work done will be equal to 0. So now we have to consider a perpendicular line, uh, along arrow. Okay, this is the source charge. Source charges means the rho L, line charge density. Okay, and this is along the row. This is our point of observation. If we move a charge from B to A against the electric field, this is our initial point, this is our final point. So how much work will be done? Okay, so we have to find this work done. So okay, W is equal to minus Q rho L over 2 pi epsilon naught rho, minus indicates work done is done along against the electric field, dot the distance have been traveled in the direction of rho. Okay, look, the distance have been traveled along this, along a row. So dot product of arrow with arrow, we will get this. Now uh, uh, moving, applying the integration, okay, of arrow, keeping these outside the integration because these are acts as a constant for row. So only the row is the variable. Okay, where in the integration is applicable with respect to d row. So 1 over row, the integration of 1 over row is ln of row, because as we have already studied in FAC, the integration of ax with respect to dx is how much? Ln of x. Okay, so ln of a row, putting the values, b is the initial point, a is the final point. So ln of a divided by b. So if you want to remove this minus, so we can write this as ln of A minus B. So taking minus common, we can write ln of B minus A, ln of A. Okay, so this minus will be cancelled out with this minus. Okay, plus minus into minus plus. Okay, so answer will be in term of plus. And now we can write according to the log rule, we can write ln of b minus ln of a as ln of b divided by a. Okay, so work done in moving a charge along a row against electric field will be like that. Okay, so now, what is the potential? The work done in moving a charge, the amount of the energy required to move a unit positive charge against the electric field from one point to another point is known as the potential difference. Okay, so this is the external energy required. Okay, so as we know that V is work done in moving a unit positive charge from one point to another point against electric field. So V is equal to W by Q. The value of W we have already studied is this. Okay, so this is the W, and now this Q according to definition of V. So this Q will be cancelled out with this Q. We will left with V minus B to A E dot D. This is the dot product. Okay. Okay, for example, the distance of the source charge and the point of observation B, initial point, is RB, and the distance between Q and the point of observation A is RA. So E will be along AR means radius, spherical coordinate system. So we can write VAB is from B to A. Minus indicates the work done is required against the electric field. E dot AL. So DL is along AR, the dot product of E and DL. This is E, this is DL. Both of these are along the AR radius. So by by applying the dot product, we will get this. Okay. So the first step was dot product, then applying the integration. So the integration will be 1 over r square. So the integration of uh, r raised to the power minus 1 is minus 1 minus 2 plus 1 divided by minus 2 plus 1. Okay, so we will get minus, this minus will be cancelled out with this minus, we will get plus. Okay, and we will get r which is the power minus 1, which is equal to 1 over r. So this is 1 over r. Putting the values of the limits a and b, so we will get 1 over ra minus 1 over rb. Okay, if you multiply this with this, we will get the electric potential at point A. And when we multiply this with rb, we will get the electric potential at point B. So VAB, so VAB means the difference of the potential at A minus the potential at B. So later on, we will do some numerical problems. So in this, we will have to find VPQ. So VPQ means VP minus VQ. Okay, where P is the final point and Q is the initial point. Similar is the case. This is initial and this is final. Okay, so electric potential at a point, or absolute potential, means the and the other point is at infinity, means outside the electric field. For example, if we have a source charge Q and we are applying a force on moving a unit positive charge from infinity means outside the electric field. Okay, this is plus Q. Moving a charge from this to point, for example, point A. Okay, so how much will be the work done or the electric potential at this point VA? We have to find this VA. Okay, so VA is Q divided by 4 pi epsilon naught 1 over RA minus 1 over RB, where RB is at potential at infinity. So 1 over infinity is equal to 0. Okay, so we will get VA is Q divided by 4 pi epsilon naught RA. Okay, now we have to solve some numerical example on the basis of these electric potential. So the first example was 4.4, and we have three parts. A is we have to find VPQ. Okay, P is given, Q is given, E is given. And second part we have Vp is equal to, we have to point Vp where Vq is equal to 0. Okay, and third part Vp and again Vq is equal to 0. Okay, so for the first part, the paths, three paths are given. So the mm, the initial point is Q and the final point is P, and we have to point the potential at three different paths: Q along C1, along C2, and along C3. Okay, so first we will start with path C1. We, so for the potential of C1, we called it as V1. Okay, for the potential for the C2 will be V2, and the potential for C3 will be V3. Okay, so V1 is minus integration E dot dl. So the first step is you have to specify the dl, that what is the direction of dl. Second point is the dot product of E dot dl. Okay, and the third step is applying the integration. Okay, and the fourth point is putting the values, the limits of integration. Okay, limits of integration. So remember these 4 points. Okay, on the basis of these 4 points we have to solve this numeric. So first of all specify the dl. So as x is only changed from 4 to minus 7, y and z remains unchanged 1 and 2. So the dl will be along ax in this case. Okay, c1. In c2 it will be along y, and in c3 it will be along z. So dl is along ax. Okay, so first step was solved. Now the dot product, this is the dl. Okay, and now the dot product, this is the dot product of e and al. So only the x portion will be multiplied. This is because if you multiply this ay portion, az portion with this, it will be 0 due to the dot product. So applying the dot product, we will get this. This is the dot product. Second part has been done. Now moving to the third part, integration. So apply integration 6 over x square, x raised to the power minus 2. Applying, we will get 1 over x. And now fourth point is putting the limits of this minus 7 and 4 in this 1 over x. You will get this. So simple. Okay, the same is the case with path c2. Now the dl is along ay because only change is observed in y portion. Okay, so this is along ay, dot product, integration, and then putting the values, we will get 0.85. Now for the path c3, the dl is along az because the changes occur along az only. So dot product and integration, and then putting the limits, you will get this 3. So now the total amount of energy required to move a positive charge from point P to point Q is Vpq is equal to V1 plus V2 plus V3. So adding sum up these three potentials, we will get Vpq is equal to 8.2. This is Vpq. Now in part B, we are given that Vq is equal to 0. So as Vpq is equal to Vp minus Vq, as we have discussed earlier, VAB is equal to VA minus VB. So here we have VPQ that is equal to VP minus VQ. VPQ is equal to 0. This is given. Okay. So now VP is equal to VPQ, and we have already found VPQ, which is 8.20. So this is also equal to VP because VQ is equal to 0. Okay. Now for the third part, we have given three paths again. These are the three paths. Okay, so the same as it was we have done in part A. We have three paths. The first we have the changes occurred in along X. In part 2 the change occurred along Y and then along Z. Okay, but with different points. So again these four steps will be applied. First, we have to specify the direction of a DL. This we have observed that only changes occur along the x. No changes occur along y. This is 0. This is initial point is 0. Final point is 0. Initial point is -1 for the z. The final point is also -1 for the z. So the only change occurred is along the x. So the DL is will be along ax. Okay, because the changes occur only along x. So then the dot product of E dot DL, E is given, and then integration and then putting the limits, so we will get what uh, the v1 for the path c1. Now for the path c2, the changes occur along the ay. Okay, look, ay 0 and then 2. So dot product, then integration and then putting the limits. Okay, path c3, change occur only along z. DL specified along AZ, then dot product, putting applying the integration and putting the limits. So we will get -10. Adding up these three V1 plus V2 plus V3, we will get -8.25. So as we know that VQ is equal to 0, VPQ is equal to VP minus VQ, and we are on the required is VP. So -8.285. Okay, this is actually the value of VPQ, but now VP is equal to VQ because VP is equal to VP because the VQ is equal to 0. Okay, now moving to the second example, that is 4.5. So we have given source charge 6 nanocoulomb. VP, sorry, P point is this minus 0.2, zero point 0.4, minus zero point 0.4 and 4. We have to find VP at 3 points. When one point is at infinity, the other is at 100, and the third one is along this. Okay, so VP is equal to this according to the formula. So we have to find V potential at point P. So for this, we must have to know RP, the distance from the point of the source and the point of observation. So here we have P minus 0.2, minus 0.4 and zero point 0.4. So square add up and taking the square root, we will get RP is 0.6. Okay, putting RP in this, we will get Q is given, which is 6. Okay, so 6 4 pi, and this is RP. So this is VP. As we know that the potential difference between 2 point P and Q is given by Vpq is equal to q divided by 4 pi epsilon naught 1 over rp minus 1 over rq. So the rp has been found. This is zero point 0.6, but now you have to find the rq for 100. So 1 square plus 0 square plus 0 square whole square root, you will get rq is equal to 1. Putting the values of rq in this equation, equation 2, we will get vpq is equal to 36. So as we know that vq is equal to 0, so vpq is equal to vp, which is equal to 36. Now we the same example but with different q values. Here the q values are minus 0.511. Okay, so applying the same method, square 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 sum up and square root, we will get 1.5. Putting the values of rp and rq in this equation, equation 2, we will get vp is equal to 0. So the very simple, remember these 4 steps, and then you go for solution. So the solution will be easy. So this is actually a roadmap for you people. Okay, very simple. So do it. If you have any problem, you can ask me in group. Thank you.